Now we are going to discuss about behavioral modeling. This The behavioral model indicates how software will respond to external events. Okay, this model indicates it indicates how software will respond to external events. What is the external event? Okay, whoever the user is there, the user is called the external event here. If that user, okay, will if that user wants some service from that app, then how that app will be respond to that particular user. Okay, so that is called a behavior of that project, okay, or behavior of that particular system. Clear? So to create the model, the analyst must perform the following steps. If we want to create behavioral modeling, then the analyst must follow the below steps here. Clear? So first of all, evaluate the all use cases to understand about that what is that particular product and how the customer will interact with that. What is the software product which we have developed? If one user wants to use that particular product, how it is respond to that particular user, right? Suppose now I'm going to use this particular Zoom app. How this Zoom app is supporting to me? Now I am the end user to this Zoom app. I am the one of the user. So whenever I want to make a make a moment, make a meeting. Okay, I want to conduct one meeting with you. So how it is supported to me? What it is going to ask? First, it will ask the login credentials. After using my login credentials, which means first of all, it will ask some registration. If I will be registered by using some Gmail ID and with the password, it may be a new password, then okay, it will be saved those two. After that, okay, it will allow me to use that particular what services of that Zoom app. What are the services that Zoom app will be provided? One service is joining a meeting. Second service is scheduling a meeting. Third service is some conduction of meeting, like that. It will provide many services to me. Okay, I'm the end user here. So if I want to use, okay, schedule a meeting option. If I want to use schedule a meeting option, how it is responsive? If I will click on that particular what icon, how it will be responded to me? Okay, right. So that is the things here we are going to discuss in behavioral modeling. If one user should use one app or would use one app, how that app is supporting to that particular user. So by using use case diagrams, we would represent the user actions as well as the system actions. I mean, okay, how the user is interacted with that particular app Zoom app, and how that will be responded to that particular user. Okay, this representation clearly will come under, okay, use will come in use case diagrams only. That's why first of all we should analyze, or we need to analyze that use cases carefully to understand that okay, response, interaction between end user and that particular system, right? Next, identifying of events. So events in the sense, what are the actions here which are we are going to perform? If I'll click this one schedule meeting, what it will give the responses to me? If I'll click join a meeting, what it is going to ask me? If you will click on the join a meeting option, then it will ask meeting ID and a passcode, isn't it? After that, it may ask you want to on video option or not, or if you want to on audio option or not. Okay, like that, it is asking many questions, isn't it? If you will choose a join a meeting option from Zoom meeting. So if it is the same, that concept only, so what are the events into that particular join a meeting option? How we are going to handle those? How those are related to our meeting? If it is, if you are not interested to enter the login credentials, what happens? If you'll enter wrong credentials, what happens? Okay. Okay. So if you'll enter right credentials, then what happens? If you will enter right credentials means you may join meeting, isn't it? You may join meeting and listen everything whatever I'm teaching. If you are enter wrong credentials, you won't enter into this meeting. If you are not interested to type even login credentials means just keep quiet. No need of no need of doing anything here, right? So like this, first of all, identify the events, okay, which drive the interaction sequence and understand how these events related to specific objects. Next, create sequences for each use case. Have discussed this point in yesterday's class itself. Creation of how many use cases we have drawn. Here there are individual schedule module, join a meeting module, like the different modules are there into this particular Zoom app. So for each and everyone, you should get ready one use case. After completion of all the use cases, you have given some numbers to that use cases and make them in order. Okay, then after that, build a state diagram. Okay, then review behavioral model and verify a accuracy and consistency. Okay, after drawing some, after building some state diagram, then review the behavioral model. What is the behavior? And write down that behavior of that particular model, which means events, actions, right? So this is about behavioral modeling. So if you want to represent the behaviors of a customer and a system, would be represented by using state diagrams. If you want to draw behavioral modeling, it is possible by using state diagrams or by using sequence diagrams only. Those two diagrams, okay, will give clear explanation or information about the behavior or interaction between system and customer. Clear? So that's why here one point is the build state diagrams. Right? Now we are going to discuss about state diagrams in next slide. State representations. Now we are going to see what are the state representations. So in context of behavioral modeling, two different characterizations of states must be considered. Two different characteristics are there for a single state on behalf of behavioral modeling here. So what is the first characteristic? The state of each class, the state of each class as the system performs its function. Okay, the state of each class as the system performs its function. And if you see the second one, the state of the state of the system as observed from the outside as the system performs its function. What is the first one here? Okay, what is the state of a class? In between oral project. Here the project may be implemented into a in the form of different classes, isn't it? How the class should be executed a function. Okay, whatever the classes which are there in particular system, how those classes are executed or execute some function. And coming to the second characteristic, okay, the state of system as observed from outside as the system performs its function. How I mean at the end of at the place of the customer state, how the function is performed. Okay, we're going to be observed here. There are two states. First thing at the place of class, second thing at the place of at the class, and second thing at the place of external entity. External entity. So these are the two state characteristics here. And also, if we are going to see again, okay, the state of a class, the state of a class takes on two passive and active characteristics. Again, the class can be represented into two characteristics. I mean, class have two characteristics. First one is a passive state, second one is a active state. The passive state simply the current status of all an object's attributes. Okay, what this passive state indicates? Okay, it will indicate the current status of what is the present status of all object attributes. Whatever the objects involved into that particular project, okay, it will give the status of those objects, present status of those objects. That is called a passive state. If we'll see the second one, active state. Active state of object indicates the current status of the object, current status of the object as it undergoes a continuing transformation or processing. How the object is working, I mean, how the object is processing, what are the operations based on that particular object. Passive state includes or indicates the attributes of a object, current status of a attributes of a object. Active state indicates that operations of an object, current status of operations of an object. The operations in the sense it's a called processing, isn't it? So the processing of an object. This is about state representations. Now we will see one small diagram for this is the state diagram. Okay, state diagram also called state chart diagrams or state missions. There are two more names are there for this state diagrams. What are those? State chart diagrams or state missions. State missions or state diagrams are the diagrams. By using these diagrams, we can represent the behavioral behavioral modeling or behavior of a system with a end user. Right. These are used to represent the behavior of a a system with end user or behavioral modeling, whatever it may be, right? This diagram is for if suppose we have some control panel. If suppose assume that here I'm having some what laptop. Now we have one laptop here. So if I want to work with a laptop, how it should be controlled one user, how it would be controlled a user. See here, first of all, hit a key, which means click on some what hit a key in the sense it's a click on start button, right? After clicking on the start button, then I mean after clicking on start button, or okay, it will ask for the credentials, login credentials, whichever I'm entering regularly. So now here at this place I have typed some login credentials to my system. Then it will read those login credentials. Okay, after entering the password, it is going to do the action of comparison. Okay, whenever I'll hit some key from my what control panel, which means from my keyboard of a laptop, then it will be coming in a read mode. Okay, read mode. After that it will open some what text box. Into that text box, suppose if I have entered some password, after that it is going to check, which means comparison. So if that password is a valid password, if it is a valid password, then this state will be executed, what it is selecting. Okay, and it will be activated for the work, whatever the work I want to do with my laptop, it will be allowed me if I'll enter a correct password. Suppose my password is wrong. Suppose my password is wrong. Again, it will be asked for many times. Okay. One time, two times, three times, four times, like that. It will be asked for some maximum number of times. Okay. Then also, I'm entering a wrong password. Then the system is automatically going to a lock state. Automatically the system is going to a lock state. Automatically it will be I mean hang out, or it is locked until the there is a lock. If I will set the some lock time. Until the time it won't open. If the time is over completed, the lock time is 1 hour or 2 hours or 24 hours. After 24 hours again I'm opening and try to open a laptop here. Again enter the password. Okay, if it is a correct password, then it will be allowed me to work with that computer. Otherwise the same process will be repeated. Okay, this is called one control flow system for my laptop. How my laptop is protected? By taking this particular password. Okay, if I am the right author means I'll enter correct password. If not means I may that they may enter wrong password. So it's not opening for them, isn't it? So this is one of the barrier or control. Okay, for my laptop, isn't it? Right. So the control is necessary for any app, any kind of gadget, or any individual single app nowadays, isn't it? To provide security. Okay, So this is the example for control panel. Here we are having okay, this is the state chart state diagram or state chart diagram. Okay, here we are having only two kinds of symbols, three kinds of symbols. Observe here we are having one is just what just like one big bubble is there, that is one symbol. So this is here you have this big bubble symbol, one symbol that is to represent starting and ending states. Okay, that symbol is used to represent starting and ending states of a what action. Next, here we have more two symbols. This is one symbol. Which one? Reading box, locking box, selecting box is one symbols. These are all called states. Okay, these are all called the states here. State symbols are states. Okay, so what kind of actions we are going to perform? Those are the states here. And next, you may have one more symbol. So this is like this. So this is the third symbol you have. Comparing. So this symbol is called composite. Okay, uh, composite state symbol, which means composite means it's a combination of more than one activity which is related to a single thing, isn't it? So that is called a composite. Here also the same meaning will carried by this composite symbol here. It may be carried, okay, the actions also within itself. States are different. States are only actions, but this is the something, the process. Here we are doing some process related to a entered password. What we are doing here, just comparing the password. If that password is correct, then it will allow us to do the work with the computer. Not it will be going to a locked state, isn't it? So this is the composite state symbol. And fourth means these are the arrows. Okay, single-ended arrows are there. Single. Okay, for each and every. These are the connections in between. No, these are called transitions. Transition. Okay, these transitions are used to move from this single uh, single-ended arrows, whichever we are used into the state diagrams, are called the transitions. These are used to connect or move from one state to another state, right? So these are the transition symbols. This reading, locked, selecting, these symbols are the state symbols. And this circle is called, which means this bubble is called the starting or ending a state's representation. And this the middle one is called a composite state symbol. Within this composite state symbol, it may execute some functions, small functions related to that particular concept itself. Okay, so that is called a composite symbol, right? This is about the class diagram, sorry, state diagram. And here again we are going to discuss about states of a state system, which means so already I have shown you what is a state symbol, what is a transition symbol. Okay, events or actions, event and actions, just if something, if s, what we have to, I mean it will check event in the sense it's just boolean thing, whether it is true or false. Event means it is a boolean action for relating to some question. If it is true, it is going to perform some action. If it is false, it is going to perform some other action, isn't it? So this is also we have seen in earlier classes, right? So clear about this. Here we are having some states or symbols of a state diagram. What are those? State, transition. What is a state here? A set of observable circumstances that characterize the behavior of the system. What the system needs to do there. It is going to lock, or it's going to do action. Which action? Reading action, locking action, okay, or otherwise continuing action. Which kind of actions the system is going to perform, that will be, okay, represented by using a state symbol, right? And state transition, this state transition in the sense, the movement from one state to another state, the movement from one state to another state will be represented by using a single, okay, headed arrow symbol. Okay, next, event is this, event is a result whichever will get after comparing a password, okay, my password with already system password. If it will be matched, the result, okay, matched means it will return true, true. So true means it will be, the system will be opened for me, that is the action. The event will be the false, the system automatically will locks after number of trials. Clear? These are the states. Next, same, the behaviors of this state diagrams will be represented in again the behavioral modeling here. So what is the first step here? Make a list of the different states of a system. Okay, how does the system is behave? First of all, you need to make some, okay, list of different states, which means list of different actions which you need to perform, within that particular project. After making the list, you need to indicate how the system makes a transition from one state to another state. How we are going to make a, I mean, make a relation between one state to another state. Okay. Next, indicate event and indicate action. By remembering all these, you should draw state chart diagram or a sequence diagram. Okay, first of all, what are the actions which would be performed into that particular project? You should list out them. After that, so which one is first, which one is second, from where to where we need to make the connections, okay, or relation is there between states. You should identify those states and try to, okay, give the transitions in between states. After that, where you need to provide the actions, okay, I mean, these are the resulting actions, not the first one. These are the resulting actions. If the event is true, which kind of result we should get? If it is false, which kind of results we should get? Like that, you need to implement that one, right? In next slide, we are going to see a small sequence diagram here. This is the sequence diagram. Till now we have seen state chart diagram. That is a state diagram. This is a sequence diagram. In this sequence diagram, actually we are I mean putting the all the actions, which means all the people or systems whoever involved into this particular project will be, okay, defined like this: home owner or laptop owner, control panel, system. If it has some sensors, so those are the sensors will be represented here. After that, whatever the process till now we have discussed, that will be represented into this diagram. Okay, starting state, and if the system is switch on that system, then type the password. I mean, type the password, then it will read the password. In next state, it is going to compare the password with the system. If it is okay, if it is correct, then it will be allowed to work with the system, allowed to work with the system. Otherwise, okay, it will go back to block the, sorry, block the system here, right? Before blocking, it will ask the number of times, it will give the permission to the number of times to enter a password, correct password, isn't it? So this is a sequence diagram, the same concept. For which purpose we have drawn that state chart diagram? The same, this is one kind of representation. So if you want to represent behavioral modeling, then you can represent by using either state chart or a sequence diagram, that is your wish. Okay, now next slide, we are going to discuss about this is nothing. Okay, patterns for requirements modeling. This is the another concept. Patterns for requirements modeling. Okay, generally whenever we are going to model requirements, then here we would use some use cases. Okay, the best modeling technique to represent the requirements of a system is called a use cases. Okay, uh, then now we are going to discuss about the patterns for this modeling, patterns for this modeling. First of all, see the first point, software patterns are a mechanism for capturing domain knowledge in a way that it allows to be reapplied when new problem is encountered. Software patterns are used, okay, uh, as a templates, as a templates for implementing a new kinds of problem. If the customer will come with one problem, okay, or one project statement, how we are going to deal, whether the customer is telling something, so like that any kind of patterns are there or not, we are looking for the existing patterns. Okay, suppose if one customer is not only for project, if one customer wants to wants some wedding card, okay, he used to tell some wedding card design colors or something. Okay, I want my wedding card is like this, like this, like this. Okay, he has given some set of what his interest on that particular wedding card. So automatically what you are going to think, so with that same features, any other wedding cards are available or not, available in my shop or not, or available in market or not. Okay, did I saw anywhere? Did I see anywhere this kind of okay wedding card model or not? Like that you are thinking. So these are all called the patterns. These are all called the patterns. What is a pattern here actually? The pattern is a one model, okay, already one model which is suitable for many kinds of projects. It is already one wedding card model, okay, that may be suitable for many people. Many people may tell only the same features of that particular wedding card design or model. Okay, so here also the software patterns, in the sense these are some mechanisms. Okay, those are developed, those are already existing developed mechanisms. If one problem is came, okay, then we are assessing that problem is fit into which kind of pattern, or which kind of pattern is suitable to that particular problem. So this is the simplification of work here. This is the simplification of work. Patterns in the sense just predefined models. Predefined models. So those, by using those models only, we may think by what, based on those models only we are going to think about a new existing problem, right? And the domain knowledge can be applied to a new problem within the same application domain. Okay, if that is suitable, one wedding card is almost the features are suitable means we may fit, we may change little bit that particular wedding card by changing the names of what bride and bridegroom. After that, some parents names, after that little colors is going to add to that particular wedding card. So like that, sometimes there may be matchings will occur. Why? Because whenever the wedding card developers or designers are there, so they'll be developed based on the many people requests. In previously, many people are requesting such kind of, okay, I want this kind of card, if it is available it may be good, like that. They are listening many people interests, and by based on that interests only they'll develop a new design. Okay, after developing one design that may be suitable for next generation people, okay, that may be asked by many people. So like that here also, okay, whenever we are going to, okay, implement some use cases for one, we are going to implement some use cases for one problem. So those use cases may be apt for some other problem also. The that designing, that models also suited for some other applications also. If it is a customer related applications means the same things will be done. If it is a Google Pay or if it is a Paytm, some things will be the same, some interfaces will be the same. So in such a cases, you may directly use Paytm front page user interface design to a same phone pay front page design user interfaces by just changing one or two things. That's it. Okay, so like that. Now, the original author of an analysis pattern does not create the pattern; he may discover the pattern. So, whoever developed first a universal model, a universal use case for many projects, so that person, okay, is not create that particular project. He may discover that project. How we are going to tell that? Okay, that particular person is discovered, not created that particular pattern. Pattern in the sense, it's a just design model of, or design model of a problem, or it's a design model of a use case, right? That use case may be suitable for many projects. That is called here pattern. Once the pattern has been discovered, it is documented. After discovering a new pattern, automatically that should be documented. That would be saved for future purpose, right? This is about patterns for requirements modeling. Here the requirements modeling in the sense, if you want to model the requirements of a customer, then you need to implement the use cases. Whenever the use cases are needed for many applications, then you should discover one superb use case that may be suitable for universal wide. Such kind of things you can discover. That new one is called a pattern here, right? And now discovering analysis, here one more small concept is that is a discovering analysis pattern. So the most basic element in the description of a requirements model is the use cases. Already we have discussed about this point also. Okay, a coherent set of use case may be serve as the basis for discovering one or more analysis pattern. So whatever the first developed use case may be used for, okay, apply for many projects something. And if we'll see the third point, a semantic analysis pattern. SAP is a pattern that describes a small set of coherent use cases that together describe a basic generic application. So this is completely, these two concepts completely related about this one and the pattern one. Both will be related to a discovering a new use case. That new use case will be a suitable for any kind of uh, problem statements or many kind of problems which are suitable for maybe same similar projects itself. Okay, this is about today's class. In tomorrow class I'm going to discuss about